Welcome back. Quadrants. The signs of the x coordinate and y coordinate affect the location of the points. You may have seen some patterns. We summarize that pattern. If both x and y coordinates are positive, you are in quadrant 1. If x is negative, y is positive, you are in quadrant 2. They are both negative, you are in quadrant 3. When x is positive, y is negative, you are in quadrant 4. Let's look at our pattern. This is quadrant 1. Notice both x and y coordinates are positive. This is quadrant 2. Notice x is negative, but y is positive. Alright. This is quadrant 3. Both are negative. And this is quadrant 4. X is positive and y is negative. So how does it go? Quadrant 1 is here. How does it look like? Both x and y coordinates are positive. Quadrant 2 is here. What happens here? X is negative and y is positive. Quadrant 3 is here. What happened here? Both are negative. And quadrant 4 is here. Quadrant 4 is here. X is positive, y is negative. All right. Continuing. Linear equation. An equation of the form ax plus by equals c, where a, b, c are numbers, constants. A and b not both 0 is called a linear equation. Alright. For example, x plus 4y equals 8. A is 1, b is 4, c is 8. This is an example of a linear equation. The equation y equals negative 3x plus 5 is also a linear equation. Well, you can move this over here, add 3x to both sides. And that's how you get, when you add 3x to both sides, you get y plus 3x, negative 3x plus 3x cancel. Move the 3x first, 3x plus y equals 5. That's ax plus by. So this is called standard form. Ax plus by equals c, that is called the standard form of a linear equation. A linear equation is in standard form when it is written ax plus by equals c. Okay. What is a solution? Well, an ordered pair xy is a solution of the linear equation ax plus by equals c if the equation is a true statement when x and y values of the ordered pair are substituted. Okay. So, the graph of a linear equation ax plus by equals c is a straight line. Every point on the line is a solution of the equation. every solution of the equation is a point on the line. This is important. The graph of a linear equation ax plus by equals c is a straight line. How is that line formed? Every point on the coordinate plane which solves this equation sits here. And every point that sits here is a solution. That's how you make. For example, for each ordered pair, so you are given y equals 2x minus 3. This line is given to you. We will soon see how to graph such lines. But they have given you a graph of this line. Question is 0, negative 3 a point on this line? Look at that. That's 0, negative 3. What about 3, 3? Is that a point on the line? Well, let's see. 3, 3. That point is on the line. What about 2, negative 3? 2, negative 3. That's the point. It's not on the line. Negative 1, negative 5. Negative 1, negative 5. It is on the line. So you know that 1, 2, and 3, they are on the line, and C is not on the line. 2, negative 3 is not on the line. Okay? Well, question is A, B, D, are these points solutions of your line? Let's check. Correct? So this is example 3.2. Okay. The equation is y equals 2x minus 3. And the points are A equals 0, negative 3. B is 3, 3. C is 2, negative 3. And D is negative 1, negative 5. So, let's look at these points again. 0, negative 3. X 0, y negative 3. That point is on the line. Okay? Okay. What about B equals 3, 3? X 3, y 3. That point is on the line. What about C2, negative 3? X is 2, y is negative 3, so you go down. That point is not on the line. What about negative 1, negative 5? Here is negative 1 and go down 5 units. That's negative 5 on the y coordinate, right? Negative 1, negative 5. It is on the line. Alright, so we saw geometrically which points are on the line, which points are not. Now let's see whether these points solve the equation to see whether A is a solution of y equals 2x minus 3. How do we detect that? Where you see x, you want to place 0. Where you see y, you want to place negative 3. And you want to see whether they are equal. So, negative 3 for y. Question is it equal 2 times 0 for x minus 3? Well, negative 3. Question is it equal 2 times 0 is 0 minus 3? Negative 3, question is it equal 0 minus 3 is negative 3? Indeed, no more questions. It is true. So, A is a solution. So notice, it is on the line, it is also a solution. Let's check again. For B, is B a solution? So these are questions to see whether A is a solution, right? Let's see. B is 3, 3. So where I see Y, I'll place 3. And where I see X, I place 3. Question is this equal this? Well, left hand side is 3. Question is it equal this? 2 times 3 is 6 minus 3. 3 is equals 6 minus 3, yes. So B is a solution. Okay, next. So B is also on the line, B is also a solution. Now let's check for C. Is C a solution? Okay, let's check. What is C? 2, negative 3. Where you see Y, you want to place negative 3. And where you see X, you want to place 2. Okay, because that's X coordinate. Question is, are these equal? On the left you have negative 3. Here, 2 times 2 is a 4 minus 3. Is negative 3 equals 1? No. So, C is not a solution. You see? C is not a solution. Lastly, you want to check. So recall, C was not on the line. It is not a solution. Likewise, is D a solution of the same equation? Question is D a solution? D is negative 1, negative 5. That's your Y coordinate. Negative 5. Question is it equals 2 times negative 1 minus 3? You see, negative 5. Question is it equals 2 times negative 1 is negative 2 minus 3. Negative 5. Question is negative 2, negative 3 is negative 5. So indeed, yes. So D is a solution. So D was on the point, on the line. You see, D is on the line and it is a solution. So whoever is on the line is a solution. Whoever is not on the line is not a solution. Okay. So with that, we'll continue with the next set of problems. All right. Until then, bye.